Okay, so today we're going to look at graphing quadratics, just like, or graphing parabolas, just like what we did yesterday with, or on Tuesday as well, where we were dealing with something like this, right? Which is what your formative was. You had to like plot, plug in the points and then figure out how to graph it, right? It'd be very similar, except today we're gonna it's just gonna look a little bit different, okay? A little bit different, but familiar, hopefully, okay? So we've seen the standard form of a parabola, okay? We saw it look like this. Okay, that's the standard form, okay? And then from that, we could find the y-intercept, which we found from looking at the c value, okay, this. Okay, whatever that number was, that was what we called our y-intercept. And then we also looked at the fact that the direction of opening. Okay, and that came from whether or not A was positive or negative. Okay. Okay, so not a huge amount of information from the standpoint that you really only get 1 point. Oops. You only really get 1 point, the y-intercept, and then also like whether or not the parabola is opening up or down. It doesn't really give you a whole lot in terms of actually being able to produce the graph. Okay, we could do it by plugging in values like we saw yesterday, or inputs and outputs, and then plotting those. But that's a little bit of a tedious process, okay? Not necessarily the fastest way to do this, okay? So the reason why we show you factoring is we then are able to take our parabola in standard form and switch it into something that's more useful, right? That's why we show you factoring. So you'll look like we went from something like this yesterday. I'll draw the arrow again. We went from something like this yesterday, and we started to learn how to produce something that looked like this. That's what we've been doing. This here is what's called factored form. Okay? And it takes on the form, it looks something like this. There's still an a value, it's the same a value, and it still tells you if it's going up or down, but then you have x minus a number times x minus another number, okay? And just to like show you like a nicer version of that, once we fill in the numbers, you can see here, this is just what it looks like, okay, with numbers filled in, where there's an a value of 1. Okay, does anybody have any questions so far? So you can see like what we've been doing. Okay, factoring takes us from standard form down to factored form. That's what it does. And then the opposite was true, which we saw yesterday. We could take something and go up to standard form by expansion. We've said that a few times over the course of the last few, like since Wednesday or Tuesday or Wednesday this week. Okay, we've seen a couple of things like this. Okay, are we okay? So what I want to do now is just to spin off of the work that we did yesterday, and then I'll show you. We'll see if we can see some patterns in what we're seeing. Okay, so much like what we did yesterday, or reviewed yesterday, I should say. Again, I have an input or a whole bunch of inputs, and what you're going to do is you're going to put these inputs into your machine. Okay, and then the machine's going to spit out outputs, right? And then you're going to plot those. Okay, so it's the same thing. So the catch with this today is that the machine just looks different. But funny enough, it looks different, but we produce the same graph. So it's kind of like a second machine that looks different but does the same job sort of thing, right? It's kind of weird. But it'll produce the same graph as whatever it would look like after it's been expanded. Okay? But the process is the exact same. So we're just going to like plug in numbers, right? That's what we're going to do. So we're going to say, okay, well, if we were to plug in -3, we're going to get, I'm going to try. We're going to get -3 plus 1, and we're going to multiply that against -3 minus 3. Well, that looks like 2 multiplied by -6, which is going to be -12. That's going to be our output. I'm just going to try and fit everything. Okay, so then if we put our little inventory down the side, right, we're going to get -3, -12 for our first point. And then we go again. -2 plus 1 multiplied by -2 minus 3. Well, that's going to be 1 multiplied, oh, sorry. This is where things can get a bit silly sometimes if you make a little sign error. -2 plus 1 is -1 multiplied by -2 minus 3. It's going to be -5. Okay, which equals 6. Sorry, why am I doing 6? It's 5. Okay, and so we get an output of -2 times and 5. Okay, then we're just going to keep going. Right, and I suppose as you start to find these points, you can always plot them on here too. Like -3 is here, -12 is here. So where do they cross? Well, right here. There's your first point. Your second point's going to go -2, which is here, right? And +5. It's a bit of a jump, which is interesting. Okay, and then we just keep going. Okay. -1 plus 1 times -1 minus 3. That's 0. And times -1 minus 3 should be -4, which is equal to 0. So I should get -1 and 0. I feel like something's happened. Oh, I know what I did. Nobody caught it. Now, it's at this point, what's nice about when you do things like this, you guys know what the graph is supposed to look like, right? And so this is how I know I've done something wrong here. My graph can't do this, right? Because the next point's going to do so. That's going to be up here, right? Something's wrong. Okay. So we got to think, well, what is it? So I'm like looking back and I'm just looking at the little math things that I've done, and this is why sometimes this is not the best way to do this, right? But it's a way, and it's a way that we've come from, right? So I'm just trying to build you to the fastest and most efficient way to do this, right? From the standpoint that you're not going to make these little silly errors, right? And so when I look at, I'm just backtracking here and I'm trying to find where this error is, right? So I'm like, okay, if I zone in, I'm going to look at the first one, right? And I see -3 plus 1. That's not 2, right? That's -2. Okay, so you gotta be really careful. And then -2 times -6 is positive 12. Okay, which changes where my point is, right? Not at -12. It's up here at positive 12. That looks better to me. It's starting to look a little bit more like a parabola here. Okay, we're not quite done. We got to keep going with the points, but that's how you guys can catch errors, right? And look how easy it is to make an error like that. You just forget. You forget that there should be you forget a negative, and then it messes up the entire graph. You just got to be careful, right? Be very thorough in what it is you're doing. Okay, so we'll just keep going here. And remember, once we reach kind of where we think the axis of symmetry is, we know that the other half of the graph has to have those values. Okay, so 0 plus 1 multiplied against 0 minus 3. Well, that looks like 1 multiplied by -3, which is equal to -3. And so our point here is 0, -3, which is right there. Okay, keep going. 1 plus 1 multiplied by 1 minus 3. Okay, that's going to be 2 times -2, which is equal to -4. So we get 0. Oh, what am I right? 0. 1 and -4. It's right here. Okay, you can see it's starting to bottom out. Okay, I don't know if that's quite the axis, like the vertex yet. We'll do one more and then see. Okay, 2 plus 1 multiplied by 2 minus 3. That should equal. Oh, we'll do the math. We get 3 multiplied by -1. So we get 2 and -3. All right, so we know we're okay now. Okay, we know the rest of these points. If I was to you can see it bounce back, right? And so I can see where my axis of symmetry is. It's right here. Right? It's going to produce 2 equal pieces. And if I did the rest of the math, I'd see that when x equals 3, I should expect to see a 0 come out, right? And when x equals 4, I should see a value of 5 come out. And then you could, in theory, do 5, right? Because you know that 5, when I go x equals 5, it should spit out that point. Because they're always equal distances from that purple line. Right? You can see, okay, from this point to the purple line, looks like 4. From this point to the purple line is also going to be 4, because it has to be equal on both sides, right? So if I sketch this parabola, it's going to do something like this. Is everybody okay? Very easy to make one of these mistakes and get lost in a question. This is why this is not the best method to do this. Okay? Now, I just want to come down here and look at this. I'll maybe do the math on this one just to prove to you guys that these actually work out. We know that the point is going to be 3 and 0, right? And then we also know the next one, 4 and 5. Okay, let's do the math and we'll just make sure that it works. We're going to go 3 plus 1 times 3 minus 3. Well, that looks like 4 times 0, which is equal to 0. Okay, so we're good. And we'll do it again. 4 plus 1 multiplied against 4 minus 3. Well, that's 5 times negative 5 times 1. Okay, we're good there too. Okay. So you can see the symmetry. What's cool about this is you can see the symmetry in the points, right? So look. 5, 5, 0, 0, -3, -3, which means that I should expect the turning point where this parabola is kind of turning around to be right here. That's a horrible line, right? And this is what we call our axis of symmetry. Well, where do we draw it? We drew it when x equals 1, right? That's where it turns around. So that's okay. That's kind of a review from yesterday. It just looks a little bit different because the machine looks different, right? But there's a particular part of this equation which I want you guys to look at for a second. I'm going to give you a sec. I want you to find the x-intercepts, okay? So we know where the x-intercepts are because they're where they cross, where the graph crosses the x-axis, crosses there and it crosses there. If I were to write those 2 points out, or just say, okay, what are the x-intercepts? Well, they look like -1 and 0, and they also look like 3, 0. Okay? I want you guys to see where those look like they came from, or how. I guess my other question is, relative to the equation being the machine, right, for this question, where could these have come from? Is your question, right? Relative to this, the equation. Like, do you see a relationship between the equation and those two x-intercepts? Okay, if somebody notices it, can you type in the chat for me? I'm just going to try something here. Would it help if I rewrote it down here? I don't know what you guys are up to, but it's tough to tell. What if I rewrote the equation down here? Can we see a relationship between this equation and the x-intercepts? It looks like to me the x-intercepts are the opposite values of the numbers that I see in here. So, what does that mean? It means when you guys write or see an equation like this, you know 2 points right away. You know the x-intercepts. 2 points, right? Specifically, the x-intercepts. Okay, so you're like, you can identify from this equation when it's written like this. You identify the 2 x-intercepts, and you say, "Oh, these are just points. I'm going to go plot them on my graph right there and right there." Right? That's a lot more useful than just knowing 1 point, the y-intercept. Okay, but you can see how if you use the combination of both of them, right, you could produce the graph. Okay. Does anybody have any questions? Okay, you can see where the x-intercepts are. It's where the y values are 0, right? It spits them out in here. So there's one. Here's the other one. The table spits out the x-intercepts too, but you can see like the table's like kind of a laborious process, right? It takes a while. And there's a little bit of room for error, as you saw that happened to me right at the beginning. Okay. So I guess our question is like, why is this true, right? Like why are we seeing this relationship between the x-intercepts, right, and the equation? Okay. Well, it turns out to solve for the x-intercepts, we're going to set the equation we're going to say y equals 0, and then we're going to solve for x. Okay. Why do we do this? Like, does this make any sense? Well, let's just zoom in on these 2 points here for a second. If we know we're interested in these 2 points, in particular, just for this question, but for any question, if we know we're interested in the points that cross the x-axis, so anywhere along here, right? If we know we're interested in points along this line, horizontal line, its y value, or up and down value, is 0. It doesn't have any height or depth. It's 0, right? And so it's looking at, okay, well, if we know that, then those points have to be on that y equals 0 point, right? Right, because there's no up and down. It's on the y or on the x-axis, no height, no depth, right in the middle on 0. So when we come down here, we say, okay, well, we're going to set this y value to 0. Okay, and you're going to solve for x. These are what we call roots. Any of those 4 things, they're all the exact same thing. They're where the graph crosses the x-axis. Okay. So what I'm going to show you is the math, but the rule always kind of works, right? You're always going to say, okay, well, I know my x-intercepts are going to be the opposite of this. Okay, what I'm about to show you is the math behind it. Okay, so you can have one of 2 options here, right? If you know that this equation has to equal 0, that means either of these 2 pieces can equal 0, and when you multiply it by the other one, 0 times anything is equal to 0. Okay, so that just means this number has to equal 0, whatever, or that answer, or this answer has to equal 0. So when I rewrite this, it's going to go something like this. X minus 2 equals 0, or x plus 6 equals 0. Okay, and this is where the opposite sign comes in, where you like look at it and you say, okay, this is just opposite. How do I solve for x here or here? Well, you solve for x by taking or adding 2 to both sides, right? So we see x equals 2. And we see over here x equals, you're going to subtract 6 this time, negative 6. All right, so if we write those as points, well, you told me y equals 0, so the point must be 2 and 0, and negative 6, 0. Okay? The math part here is not the most, like, this normally would be like, I'd say, okay, we need to know how to do this, but really, we get the point, right? If you guys can just say, okay, I know it just takes the opposite number and then write the points. That's also okay with me right now. Okay? The most important thing is not getting bogged down in this middle area. Okay? The most important thing is that you look at this and you're able to produce the graph down here by looking at the equation really quickly. Okay? We're going to do one of those in a sec. Okay. So just as practice, let's just take a look here. Okay. All right. Well, what are the x-intercepts for this question? Well, we know it always takes the opposite sign, right? Because of the math that I just showed you. Okay. So it looks like, okay, well, x is going to equal -3 here. X is going to equal 8. And when I write these as points, the x value is 3 and the y value is 0. Those are your two x-intercepts for this question. Okay. Now, if we had more time, if this was a normal course, then the math would be a little bit more important. Okay, from the standpoint that if I gave you a question like this, you'd be stuck at looking what the opposite value is, because now there's a 2 in here, right? Which you don't know how to, like, you can't just be negative, like, it can't just be +1. Okay, you'd have to actually apply the math in this scenario, right? Where you're like, okay, 0 equals x 2x minus 1. You're going to look at that and go, okay, I don't know what the roots are, right? Or the solutions, or x-intercepts, or zeros, right? I don't know what they are. But if I solved it, well, here's a piece, there's one piece. Here's another piece. Set both of those two pieces equal to 0. X equals 0, and 2x minus 1 equals 0. Well, it looks like there's one already. It told you that one just fell out. 0, 0 is the point there. This one's a little bit harder, right? Because it's not just opposite. You got to solve for x here. So how do I solve for x? Add 1, add 1. 2x is equal to 1. Divide both sides by 2. Right? And so the x-intercept here is going to be 1/2 and 0. That's a little bit harder. Okay, but it's the same concept as what I showed you over on the side with the math. You need the math for that question, okay? Anybody have any questions? Okay, keep in mind, this is a little bit, it's not wishy-washy, it's 100% accurate. But the most important thing to me is that I provide you with an equation and you're able to produce the graph, what it looks like. That's what's important. This is just a skill to get you through harder questions like this one. Okay? Any questions? I'm going to do this last one and then we're going to be pretty much done. Okay? And then there's 4. I posted 4 of these questions in Minds Online there for you guys to try. Okay? And then I can show you how to check it. We'll do this question and then we'll check it. Okay? We'll check it a couple different ways, which is kind of cool. So I want you guys to tell me right off the top, when you see an equation written in this form, we know this is factored form, right? It's going to tell us 2 things, 2 points right off the top. It always takes the opposite sign. So I know my 2 x-intercepts. One of them is going to be at 1 and 0, because +1 and 0, because it's opposite to -1. That's one of the x-intercepts. The second one is -5 and 0. These are your 2 x-intercepts. Okay, I would say typically you would need 3 points to be able to produce this graph. Okay, you have 2 right now. Okay, so I'd say, okay, well let's go plot these points. 1, 0, there's the first one, and -5, 0, there's the second one. Okay, so you could, at this point, you have a really good idea as to where the parabola is, but you don't know something. Actually, there's one other thing you do know, though. You don't know, you can find out by looking at the equation, but you don't know if the parabola does this or this. You also don't know how high up or how low it goes, right? So you technically don't know either if this parabola does something like this or something like this, right? You have no idea. You do know it has to go through those 2 points. That's not the question. The question is it opening up or down? Well, you do know if you look at the equation, the 8, is there a positive or a negative out front? Well, there's a positive out front, which means the parabola is opening up. So you know it's doing something like this, right? The issue is now, we've now eliminated the fact that it's frowning. It's not frowning because it's opening up, because the number out front, right in this spot, is positive. It's a positive 1. Okay? So you know it's opening up, but you don't know if it's doing this, or if it's doing this, or this, or this. You have no idea how far down it goes. Okay? But you do know something else. You do know that a parabola has equal halves. Okay? And so we can find something else, the axis of symmetry. We know where the middle of the parabola is going to be, right? Where's the middle? Well, the middle has to occur between this point and this one. What's the value? 1 and -5. Where is the middle of -5 and +1? Well, we can just visually try and figure it out. Okay, well, there is 1, 2, 3, 4, 5, 6 boxes between each point. So we can count, what's the middle of 6? 3. 1, 2, 3. Right here. This looks like the middle of my graph. Oh boy, that was not good. Good thing it draws straight lines for me. Okay, there's the middle. I'll erase some of this stuff so it doesn't look so messy. Okay. There's the middle of those 2 points. So you now know, again, you know your parabola has to go somewhere through here, right? Again, though, I don't know if it does that. I don't know if it does this. Right? I don't know if it does this. We're in the same scenario, except you can see now it's a little bit neater from the standpoint that we've got this going on here now. Okay. So you guys could say, okay, you also know axis of symmetry is x equals 1. I'm sorry, not x equals 1. X equals -2. You know something else. Okay? You can see how, like, what we spent Wednesday doing, just in terms of identifying key features, is starting to come into play here. Okay? So that's stuff on formative 5. It's starting to come into play here. Right? There's really not a lot of new information here per se. Right? It's how to, the new part is identifying these key features, right, from a different equation. The key features themselves have not changed, right? It's just how to find them. So I told you all on Wednesday when we did this, the axis of symmetry always went through the x part of the vertex. So you know the vertex has to have an x value of -2. Your question is, I don't know where the y value is. the y value determines how far down or how far up you go. In this question, in particular, it's how far down I go, right? So now I'm going to start, I can figure out how far down this parabola is going to go, right? I know it has to go through x equals -2. 100%. That's not a question. Your question is, how far down does it go? Well, let's just come back to like a little conversation about our machine, right? Well, our machine has inputs, which we called x. And then when we input them into the machine, we get new outputs, what we call y. Wow. As it turns out, you guys have an input right here, right? Well, if you have an input, why don't you input it into the machine? All right, let's do that. Input it into the machine. What's the machine? The machine is y equals x minus 1, x plus 5. Well, input your value, give me a new output. Y equals -2 minus 1 times -2 plus 5. What's that? Well, that looks like -3 multiplied by 3, -9. So what's this value? What's this mean? It's the output when you input -2. So that means you go all the way down to here. You go plot that point. There's your vertex. Then you're done. You connect the dots and you're done. Okay? That's all I want you to do. That seems like a lot, and it is a lot. Okay? And it's going to take a couple of those to practice. Now, how do you know if you're right or wrong? Is your next question. Okay, well, let's do this. My keyboard. Okay, I'm going to stop the video, but I'm going to show you guys how to do something because